Welcome to a video on arithmetic series. The goals of this video are to define a series and also to determine the partial sum of an arithmetic series. The summing or adding of the terms in an arithmetic sequence creates what is called a series. So a sequence is a list of terms and a series is a sum of terms. And these are the formulas that we can use to find the nth partial sum of an arithmetic sequence. Let's see if we can figure out where these formulas are coming from. And let's do that by considering this problem. Let's say we want to find this sum, but we want to find an easier way to do it than just add all of these numbers. Well, the first thing you might notice is that this series is an arithmetic series because each term increases by 1, so our common difference is positive 1. The next thing we might do is start pairing up these numbers. If we start pairing these up, we're going to notice a pattern. What I mean by that is if we take the first term and add it to the last term, that has a sum of 101. And if we take the second term and add it to the second to the last term, we'll also have a sum of 101. And this pattern continues, so we could continue pairing these up to have sums of 101. And the question becomes, how many 101s would we have? Well, if there are 100 terms and we're making groups of 2, that will leave us with 50 groups of 101. So the sum of all of these terms would be 50 times 101, which is equal to 5050. Now if we look at this in the most general sense, meaning we want the sum of n number of terms, to find the sum we're going to create by pairing the first and last term would be a sub 1 plus a sub n. And the number of pairs we would have would be the total number of terms, which is n, divided by 2. And this is one of those formulas that we can use to find the partial sum of an arithmetic series. Now let's take a look at the second formula. One thing we'll notice is that this formula requires the last term in the series, and this formula doesn't, but of course they are related. If we were to take a closer look at this formula, we could rewrite 2 times a sub 1 as a sub 1 plus a sub 1, leave everything else the same. And if you remember from the video on arithmetic sequences, a sub 1 plus a sub n minus 1 times d is equal to a sub n. So this would just become s sub n is equal to n times a sub 1 plus a sub n all over 2, which could be rewritten as this first formula here. Let's go ahead and apply these formulas. Let's say we want to find the sum of this arithmetic series. Let's write down all the information that we know. A sub 1 is the first term, that's equal to 3. The last term we'll call a sub n is equal to 73. And we know it's arithmetic, so we can find the common difference. Let's go ahead and take 8 and subtract 3. That would be d equals 5. Remember, we can choose any term and then subtract the term before it to find the common difference. Now if we take a look at the formula to find the partial sum, we do have to find the value of n still. But we can use this formula here to find the value of n. If we let a sub n equal 73, we should be able to solve for n. Let's give it a try. A sub 1 is equal to 3. We're trying to find n, and the common difference is equal to 5. Well, here we have one unknown, so we should be able to solve for n. Distribute the 5. Combine like terms. This will be 3 minus 5. That'll be 5n minus 2. Add 2 to both sides. It'll be 75. Divide by 5. Looks like n equals 15. Now we have all the information we need to find this partial sum. The sum of the first 15 terms will equal n divided by 2, 15 divided by 2, times the quantity of a sub 1, which is 3, plus a sub 15, which is a sub n, so that's 73. So we're going to have 15 over 2 times, this will be 76, so I'll write 76 over 1. Simplify this, that'll be a 1, that'll be a 38. So the sum of the first 15 terms is equal to 15 times 38, which equals 570. Let's go and take a look at another example. Here we're given the formula for an arithmetic sequence, and we want to find the sum of the arithmetic series that it creates. So again, looking at our partial sum formula, we want the sum of the first 20 terms, since n is 20, and that's going to be equal to n divided by 2 times a sub 1 plus a sub n. So let's go ahead and write down all the information that we know. We know n is 20. We don't know a sub 1, but we can find it with this formula. A sub 1 is equal to negative 4 times 1 plus 3. So a sub 1 equals negative 4 plus 3, that's negative 1. We also need a sub n, which means we need a sub 20. So we'll have negative 4 times 20 plus 3. That'll be negative 80 plus 3, that's negative 77. So we have n, we have a sub 1, and we have a sub 20, that's all we need. So the sum of the first 20 terms is equal to 20 divided by 2 times the quantity of negative 1 plus negative 77. So we're going to have 10 times, this will be negative 78. So the partial sum is equal to negative 780. Okay, that's going to do it for this video. I hope you found it helpful, and thank you for watching.